Hello and welcome to video 4.1, which is on congruent figures. Congruent polygons, they have to have congruent corresponding parts, and that includes both sides and angles that have to match. So in my example here, if quadrilateral HIJK is congruent to LMNO, what are the congruent corresponding parts? So looking through the picture here, I have the sides matched up, so HI matches up with LM, IJ, which is this side, I to J matches up with MN, and you have to say MN, not NM, because you have to go in the same direction. JK across the top matches up with NO, and then KH down the side matches up with OL. Another way to do that too is if it's a kind of a strange looking figure, or it's turned around, or one of them is upside down or something, you can just look at the letters to match it up. H is going to match up with L, I with M, J with N, and K with O. You can look at this congruent statement to figure it out. So then the angles, H matches up with L, I with M, N with J, and O with K. So all sides and angles have to match for it to be congruent. So down here, suppose that triangle WYS is congruent to triangle MKV. So again, matching up W with M, Y with K, S with V. If measure of angle W is 62 degrees and the measure of angle Y is 35 degrees, what is the measure of angle V? Well, notice here that they give you the W and Y for this triangle and then the V for this one. So the first thing you would have to do is add up your W and your Y to see what's left for S. And so 62 plus 35 is 97, and if you subtract that from 180, you get 83 degrees for S. And because S corresponds with V, V is congruent to S. So V would also be 83 degrees. And remember that all triangles have to equal 180 degrees. That's how we knew that you take 62 plus 35, add it up and take it away from 180 to get your 83. Another example is triangle ABD congruent to triangle CBD, and you have to be able to justify your answer. Prove it. Tell me why. Okay, well, right now when I look at it, it looks like it probably is, right? But you have to be able to prove it by the markings given. And since all they're showing here is that AD is going to equal CD, and then you know that BD down the middle will equal BD, that's not enough to prove it though. You would have to know that AB equals BC, and you would have to know that all the angles would also equal, and you don't need that. You don't know that. Okay, so here's what I just said. BD equals BD and AD equals CD. That's not enough though. Plus you would have to know all three angles and be able to prove that corresponding angles are congruent. Theorem 4.1, which is a third angles theorem. It just said if two angles of a triangle are congruent to two angles of another triangle, then the third angles also have to be congruent. Again, kind of common sense. If you've proven that two of them, you know that they all have to add up to 180, and so the third one would have to be equal also. So here's a little proof we're going to do. I have some of it filled out for you, and then we'll go through the rest together. So given information is that angle A is congruent to angle D. Right here, I have the mark there. I say that AE, this side, equals DC, which is this side. EB equals CB. And then BA right here equals BD. Okay, that's what we do know. Again, I have some of it filled out, and so then we'll just go through the rest of it. So angle A is congruent to angle D. That's a given information. And then from there, remember we have to prove all three angles congruent here to be able to prove this theorem. So I know that A and D are equal. Well, because these two lines cross each other and they make an X, we know that this angle right here and this angle right here have to be equal. Why is that? ABE has to be congruent to DBC. Reason being, vertical angles are congruent. That's something that we know. We don't have to prove that. So then from there, we've proven these two, and so the two that are left are the E and the C corner. And so AEB is going to be congruent to DCB. And how do we know that? What's the rule we can use? We can use the third angles theorem, the one that I just defined. That if you can prove that two angles are congruent, then the third ones have to be. Some other information that was given to us is that all three sets of sides are congruent. That's given. So now I have proven right there that three angles and three sides are congruent to each other. So triangle AEB is congruent to triangle DCB. How do I know? It's by the definitions of triangles. Yes, we could just call it that. You have three corresponding sides equal and three, let's move that over, angles are equal. So that proves that those two triangles are congruent. So bring that information with you, and we will use it in more detail the next time I see you. Have a good night. Good night.